Ready, guys? This is Module 38. We're going to talk about assessing intelligence. Okay, so intelligence tests are basically ways of measuring an individual's mental aptitudes, meaning their capabilities, and comparing them with those of others using numerical scores. Typically, we have two different types of intelligence tests. We have what we call achievement tests and aptitude tests. So, an achievement test is one that is designed to assess what a person has already learned. So, when you take a test in my class, you are taking an achievement test. It's measuring your achievement in that material. Then we have aptitude tests, and aptitude tests are tests that are designed to predict a person's future performance. And aptitude is a person's capacity to learn. So, for example, the SAT is supposed to serve as an aptitude test to tell colleges about how well you'll do in college. It's to predict your future performance. Interestingly, SATs and the ACT are pretty similar to an IQ test. And so IQ tests are also what we call aptitude tests because IQ tests originally were designed to measure how well a student would perform in K-12 school. So they're pretty similar. So early and modern tests of mental ability. So really people started getting interested in learning about how we all have different intelligences and how we could compare these among people in the early 1800s. And we've talked about Sir Francis Galton before. He was Charles Darwin's cousin, and he was the guy who did phrenology, measuring parts of the skull. And Sir Francis Galton, he really wanted to know if there was a way for us to measure natural ability and encourage those of high ability to mate with one another. This is what we call eugenics. This is a highly, highly frowned upon practice today, but it was kind of the idea, one of a prominent idea in pseudoscience at that time. And Galton, he measured things like reaction time, sensory acuity, muscular strength, and body proportions. However, his measures really didn't tell us much. They weren't very reliable. They weren't very valid. And so it just kind of started as a jumping off point of measuring intelligence. There wasn't a whole lot we gained from Galton, though, with IQ tests. Except he really did believe that IQ was inherited, that it wasn't something that you could develop over time, that it was something you were born with. Then in the early 1900s in France, there was this man named Alfred Binet, and he worked with another man named Theodore Simon. And they were psychologists. And at the time, there was a new law that had been passed that said that all kids now had to go to school in France. And they knew that there were going to be some kids that were going to struggle at school because maybe they were English or French learners, or maybe they hadn't had education prior. So his job was to make a test to determine which kids would need special classes to be at the same level as other kids their age. And him and Simone believed that all kids do develop in the same way, but just at different speeds. He did not believe that intelligence was innate. And the way he did this is that he measured kids by what we call their mental age. So he would look at how do kids at this typical age perform. Okay, so let's say 10-year-olds are able to read, you know, advanced chapter books, let's say. He would then compare a child and their performance to that mental age. And that would tell you how mentally young or old they were. So, for example, let's say you're an 8-year-old, but you're reading at a 10-year-old level. They would be above average. They would be above IQ. So they would have an IQ of like 125 because the way they determine the mental age was dividing your chronological age, so 8 divided by 10, and then multiplying that by 100. And again, Binet did not believe that the IQ was fixed, that it grew over time. Then in America, this guy, Lewis Terman, he said that we need to make one for American children. And so he created what we call the Stanford Binet test. Terman was kind of more similar to Galton in that he did believe that IQ tests revealed our innate intelligence and that intelligence was inherited. And again, the way that they developed IQ, which stands for intelligence quotient, the actual formula originally was dividing one's mental age by one's chronological age. So, for example, if you are a 12-year-old and you're performing at a 12-year-old's level of ability, then you would have an average IQ of 100. The thing is about that old formula is that it worked well for kids, but not so much for adults. Because, if a 40-year-old scores the same as a 20-year-old, does that mean they have an IQ of 50? No. So today, the way they measure it is by looking at one's relative performance to the average, which is 100 for others of the same age. So if you score above 100, basically you are above average IQ. If you score below, you're below. Terman was also kind of problematic, and he also believed in eugenics. And then we have David Wessler. Wessler created the most popular IQ test today, which is the WAIS and the WISC. So the WAIS is the Wessler Adult Intelligence Scale, and the WISC is the Wessler Intelligence Scale for Children. And the difference with Wessler's test is that in addition to giving an overall score, it also gives you sub-scores on things like, language comprehension, things like that. And so it can be really helpful, like for school psychologists, when they give tests to assess kids for special ed, use the WISC most often. Because it can help provide understandings of where kids are struggling. Okay. And then let's talk about how a intelligence test is constructed. So there's a few things that really need to happen in order for it to be a good test. Let me move this. Okay. So first of all, in order for our tests to mean anything, they have to be what we call standardized, meaning there has to be a set of procedures that every test taker follows so that we have the ability to compare scores. Because if, Johnny takes a test and Johnny gets open note and Sarah takes the test and doesn't, well, those scores aren't going to mean much when comparing the two. So we need to have a set of procedures so we can use those time after time to have good comparisons. So the way they do this is they will, let's say I make a test. I will give that test to a representative sample of people. I'll get those scores. And then those set of scores will become like the base set. And then in successive testing sessions, we'll compare, let's say, your score on the SAT to that original kind of representative sample. And if you score above, then you score above. If you score below what they scored, then you score below. Now, typically with standardization, the scores will form a normal curve, aka a bell curve, and IQ test makers, SAT, all of those, they re-standardize their tests to make their average a specific number. So in IQ tests, they will re-standardize every so often to make it so that the average stays at 100. And the reason for this is because of what we call the Flynn effect. I don't think that's written on here, but you definitely need to write that down. Basically, the Flynn effect occurs because over time, generation after generation, IQ tests have been increasing. And the reason for this, we think, is because there's been better nutrition, better education, smaller families, and rising living conditions overall. So, for example, if a person in the 1920s, they took the Stanford Binet test, if they took our version today, they would score only like a 76. Whereas the score that we would earn on the 1920 test would be far advanced than just 100. So they have to restandardize to make sure that that average remains at 0. Then we need to have reliability. So reliability is the extent to which a test yields consistent results. Basically, the test should give you the same result if you take it multiple times. Or there are some other ways to test reliability. One method is the split half method. So let's say on the IQ test, they wanted to measure reliability. Your scores on the odd questions should strongly correlate to your scores on the even questions. That's split half method. Or your score should strongly correlate between the two alternate forms of the test, or test retest. Test retest reliability is what we call it. So, if a test is reliable, if the IQ test is reliable, if you take it at age 10 and then you take it again at age 14, you should have the same score. And so the higher the correlation between the two scores, the higher the reliability. IQ tests have been found to be highly reliable after early childhood. So like almost a 0.9 correlation. That's very, very strong. And then lastly, what tests need are validity. Tests need to basically test what they're supposed to and predict what they're intending to. So, for example, sometimes there are tests that are reliable but are not valid. So, for example, if I used your shoe size to give me your score on a test, would I get the same result every time? Yes, your shoe size doesn't change much after you've gone through puberty. But is that testing what I'm trying to test? No. So it would have high reliability and low validity. And there's two types of validity. We've got content validity. So is the test measuring what it intends to? So if I'm trying to have good content validity on my AP exams, I should test you on that content, AP Psych content. And then the other type of validity is predictive validity, the ability to predict future performance. So IQ tests have some predictive validity. The SAT has moderate predictive validity. And their goal is to try to tell you how you're going to perform later. So, the SAT has about a plus 0.5 correlation with college grades, college academic achievement. Alrighty. And I'm going to have you test